Welcome to The Explainer. If you're a researcher looking to get into brain activity, you know that the emotive ecosystem has a ton of powerful tools. So today we're going to break down exactly what's available, and more importantly, how you can get the most out of it for your work.
So here's the plan. We're going to walk through the whole journey, right? We'll start with the hardware, then get it connected, figure out what the data actually means, make sure that data is top-notch, and finally put it all to work so you can pick the perfect tool for your project. All right, first things first, let's dive in and take a look at the actual hardware Emotiv has to offer.
Okay, this table gives you a really great at-a-glance comparison. You can immediately see the trade-offs, right? You've got channel count, data rate, and the actual physical shape of the headset. Each one is really tailored for a specific kind of research, from the super high-density Flex to the totally discrete M&8 earbuds.
So, the big question you have to ask yourself is this. Are you going for maximum data density with something like the EPOC Flex, for really deep brain mapping, or is speed and convenience more important? In that case, the Insight is perfect for more applied projects like brain-computer interfaces where you need to get set up fast. Now, this is where it gets really interesting, because the form factor can totally change the kind of research you can even do. You can run those classic controlled experiments in a lab with the super stable EPOC X. Or you can take your research out into the real world, into natural environments with the M&8 earbuds, which are practically invisible.
Okay, so you've picked out your headset. The next pretty obvious question is, how does this thing actually talk to my computer?
You've got a few key options here. If you need rock-solid stability and super low latency, especially with the EPOC family, that proprietary USB dongle is fantastic. For just pure convenience, standard Bluetooth works great on most of the modern headsets. But, and this is a big one, if you're in a place with a lot of wireless noise, that specialized NRF dongle is going to be your best friend to make sure you don't lose any of that precious data.
All right, so you're connected. The headset is now sending this really rich stream of data. Let's break down what you're actually getting.
Okay, at the very bottom of it all, everything starts with the raw EEG. This is it. This is the pure, unfiltered electrical chatter coming directly from the brain, measured in microvolts. This raw signal is the foundation that everything else is built on. But here's the thing, it is so much more than just brainwaves. The data stream is packed with crucial context. You're getting motion data to see how the head is moving, you're getting real-time performance metrics on cognitive states, and maybe most importantly, you're getting these vital quality scores to make sure your data is actually reliable.
And this slide is a perfect example of how the hardware has just gotten smarter over time. Think about it. The older headsets kind of just dumped all this raw motion data on your lap and said, good luck, you figure it out. The modern headsets do all that heavy lifting for you, using onboard processing to give you these clean rotational vectors called quaternions. They're way easier to use right out of the box.
Now, collecting data is one thing, but how do you know if it's good data? I mean, this is where these quality metrics become absolutely critical for doing serious research.
Okay, listen up, because if you only remember one thing from this section, make it this. Contact quality, or CQ, just measures electrical impedance. It's a necessary first step, but it can be really misleading. I mean, you could put a headset on a table and get good CQ. But EEG quality, or EQ, that is the real deal. It uses a machine learning model to make sure you're actually recording a high-quality brain signal. It's the gold standard.
So why is EQ so much smarter? Well, it's because it's not just looking at one thing. It's like a three-point inspection. It takes that basic impedance check from CQ, combines it with a machine learning model that knows what good EEG looks like, and it checks the signal's amplitude to make sure it's strong enough. It's a much more complete picture of your data quality. Okay, so you've got high-quality data streaming in. Awesome. Let's look at the two main ways you can actually put it to use.
So the first path, which is kind of the classic approach, is offline analysis. You basically just record your entire session, and then you export that huge, rich data set to dig into later with other powerful software tools. And what's great is that Emotiv Pro makes this super easy. It supports exporting to all the standard formats. This means your data is going to be compatible with all the big-name analysis tools out there, whether you're a MATLAB person, a Python person, or you use something specific like EEGLAB.
And check this out, the precision is just nuts. There's a built-in feature that automatically corrects all the timestamps after you record, getting them accurate to within half a millisecond. Now, for some types of research, that's just nice to have, but for something like an event-related potential study, an ERP study, that kind of timing accuracy is absolutely critical. Okay, but what if you don't want to wait? What if you want to use that data as it's happening? Well, this opens up a whole world of real-time feedback, interactive experiences, and brain-computer interfaces.
The magic behind all this real-time stuff is a technology called the Lab Streaming Layer, or LSL. The easiest way to think of it is like a universal translator, or a digital switchboard for live data streams. It lets all your different programs and devices talk to each other in perfect time.
And trust me, LSL is a total game changer for complex experiments. It lets you sync a stimulus on a screen with the EEG data down to the millisecond. It lets you bring in data from an eye tracker or a heart rate monitor and sync it all up. For any serious real-time research, especially with ERPs, this kind of high-precision timing is just everything.
All right, we have covered a ton of ground: the hardware, the data, how to use it. So let's bring it all home and help you figure out which tool is the right one for you. The bottom line is, the best choice really comes down to your research question. If you need the absolute maximum number of channels for things like source localization, you want the EPOC Flex. For a high-fidelity, reliable lab workhorse, the EPOC X is your go-to. For quick BCI prototypes or usability tests, the Insight is perfect. And if you need to get your study out of the lab and into the wild, it's got to be the MN8.
You know, the ability to precisely measure what's happening inside the human brain, it's not science fiction anymore. The technology is here and it's accessible. So the only real question left is the one right there on your screen. What will you discover? Thanks for joining us on The Explainer.